Hello everyone. First of all, introduce myself. My name is Fadyah Rahmanina. I'm from Group 1 of HSE Group. So today I'm gonna talk about the hierarchy of water sampling experiment that plays at the President University Laboratory. So first of all, what is hierarchy? Hierarchy is a hazard identification, risk assessment, and risk control. So this is one of the way of how we get to know the risk and how to quick control the risk of the hazard that we face in during doing our work. So in this case, we want to talk about a water sampling experiment. So first of all, I want to talk about the water sampling experiment. What is a water sampling experiment that we talk about here? So water sampling experiment is sampling the quality involves measuring the physical and chemical characteristics of water in specific location at the time of sampling. This process is crucial because certain parameters such as temperature can change phase. The validity of the data that is obtained through field sampling can be compared to laboratory measured data, provided that the field instruments used are well calibrated. In this measurement, those taken directly at the site of the water body are often essential for interpreting broader water quality results. So, water sampling experiment as we take a sample for a certain place and we put it in a laboratory to measure the parameters such as temperature, pH, turbidity, and all. So in this time, we want to talk about how the water sampling experiment can be assessed and what is the risk of these experiments.
Hello everyone, my name is Tamaria Sidabutar and now I want to explain about flow of hierarchy methods. So for the flow is begin with start and then identify HIRA objective, determination of observation parameter, risk assessment, implementation of control measurement, implementation and supervision, evaluation and monitoring, and the last is reporting and follow-up. So for the first is start. The main idea of this stage is to be discussed and observe and determining the location of observation. So this stage was carried out by the author in President University for several days. The next is identification of hierarchy objective and for this stage is aims to provide a clear picture and direction in the hierarchy identification process to match the purpose of the hierarchy itself. The identification of hierarchy objective was carried out years before determining of observation parameters. So for the next step is determination of observation parameters. This stage is the one of the important stage in hierarchy analysis, which aim to make the observation more focused in one topic and on one type of hazard and risk in a work environment. And then the next flow is the risk assessment or hazard identification and hazard prioritization. This stage also is a fairly important stage in hierarchy analysis. Why? Because the hazard identification will be carried out on the parameter which is the water sampling parameter, and this carried out by student during water sampling activities. The purpose of hazard identification is to know what the hazard should be considered and then the hazard prioritization can be determined based on the likelihood and then severity or consequences. The next flow is implementation of control measurement. For this stage is an advanced stage in the form of control of each hazard that has been identified. So the hazard that may occur during water sampling activities do not occur or reduce the risk of causing accident. So this stage can be done by elimination. It means eliminating hazard, and then substitution, replacing hazardous materials with safer materials, and then engineering administration, which is changing the design of the machinery, workplace, equipment, or work process to be safer. And then for administration, it means implementing SOP during water sampling activities. And the last is PPE, or personal protective equipment. It means use of personal needs that can protect we as a student during water sampling. For example, use special clothing or hand gloves or something else. Next step is implementation and supervision. On this stage, the implementation of each hierarchy has been analyzed. And for this stage, we as a student will continue to be carried out during water sampling activities, which will supervised by lecturer, staff, and also laboratory assistant. And next is evaluation and monitoring. For this stage, will be carried out after the implementation and supervision step. And this stage can be done when the water sampling activities carried by students have been complete. The next step is evaluation and monitoring. This stage can be done when the water sampling activities carried by students that have been complete. This stage will also be carried out by student, staff, and laboratory assistant by monitoring every water sampling activity. And the last is reporting. It means all of the activity of water sampling that have been done, and we must report our activity to the lecturer if it has been complete as a whole. For the next slide is methods. That are steps for implementing hierarchy in water sampling. That are hazard identification, risk assessment, risk control, and monitor and review. For hazard identification, this is the process of identifying the things that have the potential to cause harm. And this harm can be short or long term and can affect for our healthy and safety, and for property, and for environment, and also for the community relationship. And for risk assessment is a process to identify potential hazard, and we must analyze what could happen if a disaster or hazard occurs. And then for risk control, we develop measures to eliminate or to reduce the risk to acceptable levels using the hierarchy of control. There are elimination, substitution, engineering control, administrative control, and also personal protective equipment or PPE. And the last is monitor and review. That is the last step. It means the part of a process that involves collecting the information, the evaluating from the risk assessment and risk control, and then deciding if we have the changes if we need it.
Hello, I'm Rolia Hutahean. Now I want to explain result of HIRA. After hazard identification and work activity analysis, we summarize the data below. So the first main process, first arriving at site, hazard aspect, slipper surface, hazard scenario, slip, trip or fall on uneven or wet terrain near water, consequence, sprain, cut, brace, and broken bones. Exit control is using unslipped shoes. If you intend to take near river, prevent from falling. Is the likelihood. Next, the second example, main process is putting the sample into the beaker glass. Hazard aspect, spill water sample. Hazard scenario, slippery floor that can make someone fall. The consequence is slip and fall injuries, risks of fracture or sprain, need to clean up the spill, possible contamination of area. Exit controlnya is make sure to use non-slip shoes and make sure the floor condition around there are no spill sample that cause the floor to become slippery. So if you want know more example, you can use to read our hazard identification risk assessment. Okay, thank you.
First, let me introduce myself. My name is Nisa Patonah, and now I will give more explanation about the result of HIRA. In water sampling activities, we identified 19 hazards that may occur during the water sampling activities. Then we prioritized the hazard using a Pareto chart, which then only had 13 hazards to prioritize. The 13 hazards are hazards that are grouped as priorities that can be handled in these activities. In the HIRA table above, in addition to showing the existence of hazards that are at the medium level, we also identified hazards that are included in the low level. And risk level determination is based on likelihood, severity, and risk value. Risk level actually has 3 levels, namely high level marked in red color, medium level marked in yellow color, and low level marked in green color. But in the result of our hazard identification for water sampling activities, the hazard included in the 13 priority hazards are only at the low and medium levels. And next, for hazard number 6, which is sloping and rocky runway, has cumulative value 21. For hazard number 7, which is preparing tools, has cumulative value 23. For hazard number 8, which is data analysis using laptop, has cumulative value 26. For hazard number 9, dipping the jerrycan into the river body, has cumulative value 28. For hazard number 10, which is unexpected change of weather, has cumulative value 30. For hazard number 11, which is transporting the sample with jerrycan by motorcycle, has cumulative value 32. For hazard number 12, which is waste disposal, has cumulative value 34. And the last, for hazard number 13, which is dipping the jerrycan into the river body with the slippery surface, has cumulative value 36.
Hello, my name is Ignatius Fernando from Environmental Engineering Batch 2022. The next slide is conclusions. The HIRA hazard identification and risk assessment generally focus on assessing potential risks and ensuring the accuracy of sampling techniques. The experiments aim to identify various hazards that could compromise the quality of water sample. These include the contaminations during the collections process, issues during the transportations, or improper handling of samples, all of which could lead to inaccurate the results. Based on the findings, the experiments also propose mitigation strategies to address any identified risks during the activity. These strategies typically include the development or better protocol for sample handling, storage, and transportation, aiming to minimize contamination and ensure the sample integrity. Lastly, the study verifies that the sampling methods that happen in President University laboratory comply with relevant industry standards and regulatory requirements. And I think that's all from our group. Thank you for your attentions.